This is M.W. Penn, and I've brought Sam along to give you a brief introduction to adding fractions. Sam is actually pretty good at adding fractions. Just try to break a biscuit in half and only give Sam half of it. Sam wants both halves, or the whole thing. As you all know, a fraction is a number. So adding fractions is as easy as adding any other numbers. So first, let's remember what we do when we add numbers. We just count up how many we have. Like this. This is a picture of the beautiful polygon princess. Here we have one picture of the polygon princess. Now we have 3 pictures of the beautiful polygon princess, plus 2 more. So how many pictures of the princess do we have? Well, we can just count them up. 1, 2, 3, plus 2 more, 4, 5. We have 5 pictures of the beautiful polygon princess. This is a picture of the handsome triangle prince. We have 1 picture of the handsome prince. Now we have 6 pictures of the handsome triangle prince, plus 3 more. Again, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or we can simply add them. 6 plus 3 equals 9. So we have 9 pictures of the prince. But sometimes we have things that are not quite the same. Here we have 4 pictures of the beautiful polygon princess and 5 pictures of the handsome triangle prince. I guess we could try to add them up, but if they're not the same, what would we have? 4 pictures of the princess plus 5 pictures of the prince could equal 9. But 9 what? These numbers, they don't tell us what we have. Numbers only tell us how much or how many. 4 plus 5 might equal 9 if 4 and 5 represented the same thing. But now we have 9 of, well, we don't know, do we? Adding fractions is no different than adding any other numbers. Fractions are numbers, so we can just add them up in the same way. Here we have 4 1/4 parts of a square. Count them. 1, 2, 3, 4. And then we have 2 more 1/4 of the same square. 1, 2. So we have 1, 2, 3, 4, 5, 6 fourths of a square. 4 fourths plus 2 fourths equals 6 fourths. And that's how many we have. Here we have 3 1/3 parts of a square, and then 1 more 1/3 part of the same square. How many thirds do we have? 1, 2, 3, and another 4. We have 4 thirds of the square. 3 thirds plus 1/3 equals 4 thirds. But notice that 4 thirds of the square is the same size as 1 and 1/3 of the square. 4 thirds equals 1 and 1/3. They name the same quantity. They are equivalent numbers. The same number, really. That's interesting. We can write the same number in different ways. If 4 thirds equals 1 and 1/3, then 5 thirds must equal 1 and 2/3. And 6 thirds? Well, that would equal 2. And it does. Let's look at these rectangles at the bottom. We have 1/3 of the square 6 times. 1, 2, 3, 4, 5, 6. And it does equal 2 squares. So when we have 6/3 of a square, we have 2 full squares. Of course, we can divide a square into fractional parts in many different ways. This is a square, and we can divide it into 2 equal parts, or halves, 3 equal parts, or thirds, 4 equal parts, or fourths, or even more. And look over at the side where we have 2 1/4 parts of the square, and 2 1/3 parts of the square. Notice that the 1/4 part is actually smaller than a 1/3 part. But that only makes sense. If we divide a square, or anything else really, into 4 equal parts, the parts will be smaller than if we divided it into 3 equal parts. No, Sam, I won't do that. Look at how small 1/16 of that square is. 1/1,000,000th would be minuscule. Besides, we still have to figure out something. If the pieces of the square are different sizes, how could we add some of those 1/3 size pieces to some of those 1/4 size pieces? I mean, they're not quite the same thing, are they? So, since the fractions are different sizes, how can we add some of those 1/4 parts to some of those 1/3 parts? Here we have 3/4 plus 2/3. 3/4 plus 2/3 equal what? We know 1/3 of something is bigger than 1/4 of the same thing, so we're not adding equal pieces. We couldn't just count them up or add them together. They're different. We can't count 1, 2, 3, 4, 5 somethings when they're not the same thing. Because we can divide the square into fractional parts in many different ways, there might be a way to divide it into parts that can fit into both 1/3 and 1/4. And look at this. This is 1/12 of a square. Pieces the size of 1/12 of the square can fit into both 1/4 of the square and 1/3 of the square too. Look at 4 of those 12s equal 1/3 of the square, and 3 of those 12s equal 1/4 of the square. So 3 12ths equal 1/4, and 4 12ths equal 1/3. So 1/4 equals 3 12ths, and 1/3 equals 4 12ths. And we can add 12ths. They're all the same size. So 1/4 plus 1/3 would be the same as adding 3 12ths plus 4 12ths. And when we're adding the same thing, 3 plus 4 equals 7. 3 12ths plus 4 12ths equals 7 12ths. It's just as easy as adding pictures of the handsome prince. So we can divide a square, or anything else really, into fractional parts in different ways. And some of these fractional pieces fit perfectly into other fractional pieces. Look at this. 2/4 equal a half. 2/10 equal a fifth. 2/6 equal a third. I think this information is going to be useful. So we learned 3 important things today. We learned that when we add, we should add the same things. No adding cupcakes to caterpillars or horses to moonbeams. we learned that when we add fractions, they too must divide the whole into the same size parts. We shouldn't add thirds and fourths, or fifths and ninths. But because we can divide a whole into fractional parts in many different ways, we can find equivalent fractions, fractions that share the same denominator, and can replace the fractions that we're adding. Sam would say that's being clever. The important thing to remember is that when we want to add together fractions with different denominators, we have to find other fractional parts that equal all of those we want to add, and substitute these in the addition. Mathematicians call these equivalent fractions, and finding equivalent fractions can sometimes be a little complicated. So we'll do that next time. Today, just remember what we're doing and why we're doing it. If we want to add 1/2 and 2/5, we can find equivalent fractions to both of those fractions that have the denominator of 10. Adding 1/2 and 2/5 is the same as adding 5/10 and 4/10, and our answer is 9/10. If we're adding together 2/3 and a 4th, well, it's the same as adding 8/12 and 3/12, and the answer is 11/12. 1/3 and 2/5 is the same as adding 5/15 and 10/15, and the answer is 15/15. But look at that last fraction, 15/15. It means that the whole has been divided into 15 equivalent pieces, and we have all 15 of them. If we have 15/15, we have the whole. It's important. If we have 2 halves, it's the same as having 3/3. It's the same as having 10/10. It's the same as having the whole. So 15/15, 2 halves, 3/3, 10/10 are all equal to 1. Sam said I should put this into math speak, so I'll try. We know we call the bottom number in a fraction the denominator, and the denominator tells us how many equal parts divide the whole. When we add fractions, they must all be the same size parts. So fractions that we add must share the same denominator. 1/7 means that we've divided the whole into 7 equal parts, and we have 1 of them. 1/4 means that we have divided the whole into 4 equal parts, and we have 1 of them. And we don't want to add fourths to 7ths. So when we add fractions that have different denominators, we find fractions that are equivalent to the fractions we're trying to add, but that share the same denominator. When we find these equivalent fractions, we substitute them into our addition problem. Did I say that right, Sam? In our next session, Sam will help us find equivalent fractions. Good job, Sam. This slide presentation is a production of MathWord Press, teaching mathematics through literature. Triangle Prince and Polygon Princess are taken from the book Square Bear, A Fairy Tale of Polygons, written by me, M.W. Penn, and illustrated by Daphne Firos.